Hi everyone. This video, SOS video, is about multiplying polynomials. So a couple of reminders about the vocabulary. A polynomial is expression with two or more unlike terms. Actually, sometimes we will also include a monomial, but usually it's two or more terms. Standard form is when the terms are in descending order of the exponents. So first find the highest exponent, that's the degree of what the expression would be, and then the next highest, and so on. Simplified expression means all the like terms have been added. Okay, so when we multiply by a monomial, we could use the distributive property, and we have to remember the exponent product rule. So distributive property means we multiply every term in the parentheses by the outside number. The exponent product rule means if I have a variable to a power, say 5, and I multiply it by the same variable to a power, say 3, I am going to keep the base, that's my x, and I will add my exponents. So x to the 5th times x to the 3rd is x to the 8th. When we multiply this monomial by this one, we have to remember the exponent product rule. Okay, you're going to try these two on your own. Stop the video, try that, and then start the video up again and see how you did. Okay, and we're back. So let's take a look. Negative 3x is outside, which means everything inside the parentheses I am going to multiply by negative 3x. Since I do not see an exponent, I know my exponent is a 1. So negative 3 times 5 is negative 15. And x to the first times x squared, I keep my base and I add my exponents, x to the 3rd. I still need to multiply this term inside the parentheses by the outside term. So negative 3x to the first times a negative 4. Negative 3 times negative 4 is a positive 12, and we keep that x. So that is your final answer. Okay, we're going to multiply by 2x outside. That's really 2x to the first. And that's a good strategy to do. Anytime you see a variable without an exponent, put a 1 because that's our invisible 1. Okay, every single term inside this parentheses must be multiplied by the outside number. So 2x to the first times 4x to the third. 2 times 4 is 8. X to the first times x to the third. I keep the base and I add my exponents. Negative 2x to the first times negative 6x to the first. Positive 2 times a negative 6 is a negative 12. And x to the first times x to the first. I keep my base, my variable, and I add my exponents. That becomes x squared. And finally, 2x to the first times a positive 5. 2 times a positive 5 is a positive 10. And we have 10x. Okay, we're going to now take a look at a word problem, and we're going to need to use our multiplication of polynomials in order to answer all the questions. The dimensions of an outer rectangle are 3x plus 4 and 7x. When I talk about dimensions, I mean the measurements. So if we're talking about a flat 2D, two-dimensional rectangle, I'm talking about the length and the width. So here is my outer rectangle, and one of the dimensions is 3x plus 4, and the other dimension is 7x. The dimensions of the inner rectangle are 4x and 2x minus 5. So one of these is 4x, and the other one is 2x minus 5. Okay, now let's take a look at our questions. Express the area of the outer rectangle as a polynomial expression in simplest form. Remember, expression means I will not see an equal sign. And how do I find the area of any rectangle? Area is going to be base times height, or we sometimes will say length times width. So the dimensions of this are 7x times 3x plus 4. But that's not simplified yet, because to simplify, we carry out all operations, and we can still use the distributive property on this. Remember our strategy, this is x to the first and 3x to the first. So the outer term multiplies each of these terms inside the parentheses. 7 times 3 is 21, and x to the first times x to the first is x squared. I keep the base and I add the exponents. 7x to the first times 4, well, 7 times a positive 4 is a positive 28, and we have x to the first, or just x. And that is your area of the outer rectangle. Now, the area of the inner rectangle is going to be the same idea. We have length times width, so we have 4x times 2x minus 5. You could also say 2x minus 5, keyed in parentheses, times 4x, commutative property of multiplication. But usually we'll put the smaller amount of terms first, just to make it easier when we multiply. Okay, 4x times 2x, 4 times 2 is 8, x to the first times x to the first, I keep my base and I add my exponents. And now a positive 4x times a negative 5, positive 4 times negative 5 is a negative 20, and I carry over my x. And that would be the area of the inner rectangle. Now express the area of the shaded region as a polynomial expression in simplest form. The shading part did not show up, so I will show you what the shaded part looks like. It's everything of the big rectangle except for this inner small rectangle. So how do I find area of the shaded region? I'm going to take the area of the biggest figure, and I'm going to subtract the area of any figures that are not needed. So the area of the biggest figure would be the area of the big rectangle, but guess what? We already have that. 21x squared plus 28x minus, and we have to subtract the area of any figures that are not needed. Well, in this whole big rectangle, the only one I did not want was this inner rectangle. And you already found that area. It's 8x squared minus 20x. Now, that's more than one term, so I'm going to put parentheses 8x squared minus 20x. This is the area of the biggest figure, and we're subtracting the area of the small rectangle inside because that is not shaded and we do not need that. All right, let's remember our rules for the previous lesson. Nothing changes here, so I'm going to copy that down. And when I have a negative outside parentheses, it's the same as multiplying by a negative 1. So a negative 1 times a positive 8x squared is a negative 8x squared. And a negative 1 times a negative 20x is a positive 20x. And let's double check. If I am subtracting terms, which really is multiplying by negative 1, every term in here has to have a different sign. So positive 8x squared became negative 8x squared, and a negative 20x became a positive 20x. So we know we did that correctly. And now let's get our final answer, a polynomial expression, so no equal sign, in simplest form. That means we're going to now combine like terms. I know I should be writing my answer in standard form, so I look for my highest exponent, and I notice it's a 2. So I have 21x squared, and I'm going to subtract 8x squared, and that will give me 13x squared. Now I have a positive 28x and a positive 20x, same sign sum, and I add that together, and that's positive 48x. Since I'm talking about measurements, and they didn't say inches or feet, I'm going to write units. So the area of this shaded figure, 13x squared plus 48x units. And this has been the SOS video on multiplying polynomials.